Next, we're going to take a look at how to factor with trig identities, and it's going to be a little bit different than the GCF factoring we saw in 5.1. So our first example, what we have is a difference of squares. Remember, if you have difference of squares, you can factor them into conjugates. So think about this simpler example first. If we have x squared minus 49, when we factor that, we have x minus 7 times x plus 7, because negative 7 times 7 equals negative 49, and positive 7x cancels with negative 7x. So we're going to do something similar with our trig functions. So the square root of sine to the fourth is sine squared, and the square root of cosine to the fourth is cosine squared. So we factor that into sine squared minus cosine squared, and sine squared plus cosine squared. Remembering the Pythagorean identity, sine squared plus cosine squared is 1, so we're left with the sine squared minus cosine squared. It might be tempting to continue factoring this with difference of squares, but when you've got two different trig functions, you can't simplify it the same way you can if you only have one. So we're going to use a Pythagorean identity and substitute for either sine or cosine. It doesn't matter which one you choose. Remember, our Pythagorean identity is sine squared plus cosine squared equals 1. I'm going to choose to solve for sine squared because it's the positive term in our expression. Cosine squared is being subtracted. So if I subtract cosine squared from both sides, I get sine squared equals 1 minus cosine squared. So I'm going to substitute that expression back into just my first set of parentheses, because again, my second set of parentheses equals 1, because that is the Pythagorean identity. So we've got 1 minus cosine squared minus cosine squared, and we can simplify that to 1 minus 2 cosine squared. I want to go over this next example because it looks like a difference of squares like what we just saw. However, you should recognize this as one of the Pythagorean identities. Tangent squared equals secant squared minus 1. So again, just like on the last example, after we factored our difference of squares once, the second step wasn't continuing to factor a difference of squares. So you have to think about all the different ways that you can approach these trig identity problems. Our next one, we have a t-chart factoring, except we don't have the same trig function for all of our pieces. We've got our first one is a cosecant squared, and the second one is a cotangent. So this is the trig function, cotangent equals cosecant minus 1. Since we don't have the cotangent squared, we're going to have to replace cosecant squared. So if I add 1 to both sides, I get cosecant squared is cotangent squared plus 1. So we're going to substitute that in. And then we have one trig function that we can use to factor this one. So grouping this with like terms, our plus 1 and our minus 3, as well as putting this in standard form, we've got our cotangent squared minus cotangent minus 2. And then we'll think t-chart, what multiplies to a negative 2 and adds to a negative 1. Only this time, instead of having just x as our first term, when we factor this into the binomials, we'll have the cotangent of x. So 1 times 2 is 2, and negative 2 plus 1 gives us the negative 1 for our middle term. And our last example, we're going to use our trig functions to factor by grouping. So hopefully this looks familiar as well. We're going to group our first two terms together, and then we're going to group our second two terms together, and we're going to factor out GCF. So for my first two terms, I have a common factor of cosecant squared. So I have a cosecant left from my first term, the cosecant cubed, minus 1. I factored out all of the cosecant squared. Our second two terms, they don't have a GCF. However, I want the signs to match the parentheses in the green one. So I'm going to factor out a negative 1 so that I have positive cosecant minus 1. Once I get those terms to match, I'll factor out that cosecant x minus 1. And then what's left is the cosecant squared minus 1. And this time, because all of the functions are the same, it's all the cosecant, I can go ahead and continue to factor that difference of squares on the second one. So we've got cosecant x minus 1 times cosecant x minus 1 times cosecant x plus 1. And then I can simplify those first two cosecant x minus 1 terms as cosecant x minus 1 squared. And it just simplifies the form when you give your final answer.